Hey everybody, so in this video what we're going to be doing is we're going to be continuing on with trigonometry, and this time specifically we are going to be finding missing angles then in a right triangle. So before I show you how to solve those questions then with the triangles, we have to get into the functions that are going to allow us to find those values. So the inverse trig functions, and I've listed all of them up here up at the top. So we will read these either as inverse sine, inverse cosine, etc. Or alternately, you could also read it as arcsine, arccosine, arctangent. And we're going to be using these then to find angles in our triangles. One thing I wanted to point out, so I've put these two names here. I'm specifically going to focus on saying them like that, arcsecant, arctangent, and so on. And the reason for that is because there's some confusion with what is meant when we say something such as inverse cosine. So what I'm going to do is I'm going to show what these two are equal to. Well, the first one is going to be, since it's the reciprocal of cosine, we know to rewrite that as 1 over cosine of x. And then you should know by now that 1 over cosine is the same thing as secant. But then over on the right side, that was arccosine of x. Those are not the same thing, because secant of x over there on the left side that finds us the ratio, and remember, since it's the inverse of cosine, cosine is normally adjacent over hypotenuse, secant is going to find us the ratio of the hypotenuse over the adjacent. Whereas for arccosine here on the right side, that one is going to find an angle measure. So those two are not equal to each other. Both can be called inverse, but only the right is going to be known as arccosine. So that's why I am going to always say arccosine, arcsine, arctangent, and so on, just so it's more clear. Okay, going back to all the different types of calculators here. So once again, we are going to need to know how to do these, the inverse trig functions then on your calculator. Now, it's really tough to see, so what I'm going to do is I'm going to zoom in really far here. For a TI-84, the inverse functions are located directly above where you already did sine, cosine, and tangent. So you can see right here, it says arcsine in blue. Here it says arccosine in blue. Here it says arctangent in blue. So the way that you are going to be able to do those is that you have to hit your second button first, and then if you want arcsine, you'll just hit sine. And that's how you will get that, and then you can type in whatever your number is after that. And then the same is true for the other two as well. On the TI-89, it is a similar thing, except this time, for yours, it is in green above the Y, Z, and T buttons. So what you have to do is you have to hit the diamond button first, and then you can hit either Y, Z, or T to get your arcsine, your arccosine, or your arctangent. And then for the last one, the TI Inspire. Now, I made a mistake. I should have mentioned this before, and I didn't, and I'm sorry. You already have a trig button. It's located right there. So you just need to hit that button, and then that should take you to all of your functions. I don't recall if you happen to have secant, cosecant, and cotangent as well, or if it is just sine, cosine, tangent, but at least the minimum of what you need to be able to do is going to be found there. Since we're going to be using our calculators more often, there's going to be some calculator errors that you are going to see, and two of them that I'm going to highlight are syntax error and domain error. So what I'm going to do is I'm going to cut away, I'm going to demonstrate with my calculator how these errors occur and how you fix them, and then I'm going to come back and continue with the rest of the notes. So I wanted to just quickly show you a couple of the common mistakes that you might find when you are trying to use your calculator. So the first one is going to be the syntax error. So I'm going to just type in sine, and then I'm not going to put anything in there, and I'm just going to hit enter. And so I get this error message, and it says syntax. Now, a lot of people will just go to quit, and the thing is, the calculator actually helps you figure out what your mistake was. Not only because it says syntax, which is saying that something was typed in wrong, but also if you hit the number 2 and go to, it will actually take you then right where the error occurred. So I could say, oh, well, I meant to put it in angle, and now I can solve that. Another case would have been, let's say, I'm trying to add this, and I hit the plus sign twice, I hit enter. I can go to number 2, and again, the calculator takes me directly to where the mistake is. I can just hit delete, and then there, I can get my answer. So that was one of the errors that I wanted you to be aware of. And then the second error is the domain. So one thing for the inverse trig functions, especially arcsine and arccosine, is that you cannot put in a value that is larger than 1. So just as a demonstration, and I'm actually in radians, so let me quickly switch to degrees. So arccosine of 1 is going to be 0, so that's fine. But then let's say I'm not paying attention and I set up my ratio wrong from SOHCAHTOA, and I ended up doing arccosine of 3. Now what happens is that my calculator gives me a domain error, and that tells me then that the value entered is not allowed in the function or command. So this is telling me that what I typed in, and again I'm going to go to number 2 because now I have an opportunity to fix it. The calculator told me that I was not allowed to put 3 into the function. So I have to correct it, and maybe instead of 3 I meant to put in 1/3, and then I can solve that and it gets me a measure that is more reasonable. Okay, now that we have done that, we can go ahead and start solving these. So in order to solve these questions, we have to undo the same thing from both sides. So I'm going to demonstrate the first one, and then I will let you answer the other 5. So we have sine of x is going to be equal to 0.54. What we need to do is we have to do the arcsine of both sides. So that's going to look like this. We're going to have arcsine of sine of x is going to be equal to arcsine of 0.54. Over on the left side, those are going to cancel out. And in fact, this step here that I've just done, it's okay if you choose to completely skip that. I have no problem if you want to just rewrite this immediately as x equals arcsine of 0.54. Then what you need to do is you have to type that into your calculator. Make sure that you are in degrees, remember that. So your answer is supposed to be 32.68. And that is supposed to be a measure in degrees, so we're going to write it in degrees. Okay, now that I've shown you the first one, I want you to go ahead and solve the rest of them. Alright, now that you have done that, I'm going to go ahead and show you the rest. Now, one thing that I should have pointed out is knowing when you have accidentally found your answer in radians rather than degrees. So you need to be able to pay attention to when that happens. You're going to have a value that is a lot smaller than what you would have expected. So I'm going to just demonstrate with this first one the wrong way, radians. So if we solve this, x equals arccosine of 0.83. If your calculator was in radians, you would have gotten this answer, 0.592. And think about that for a second. Does that make sense that an angle measure is going to be less than 1 degree? Hopefully you realize most of the time, like honestly 99.99, I don't know, just basically nearly 100% of the time, we're not going to get an angle measure that is less than 1 degree. That's not really meaningful for us. So if you ever get something like that, that's a case where you probably were in radians and you didn't want that. So instead, if we switch it to degrees and we calculate the same thing, so I'm going to change my calculator over to degrees as well. This time we should get 33.90 degrees. And that is an answer that seems far more reasonable for us. So just keep an eye out for that when you are trying to solve these, and think to yourself, does this answer make sense or does it not make sense? Okay, next one then we have tangent. We need arctangent of 2.65. And that is going to be 69.33 degrees. And then just so on. So I'll just go ahead and I will fill in the rest of these. And there we go. Now we also need to know how to calculate the other three trig ratios as well, cosecant, secant, and cotangent. Now, when we are given something like this, there's a little, we have to do this a little differently. So remember, cosecant is the same thing as 1 over sine. So I'm going to go ahead and write that in. So we've got a couple different ways we could do this. We could maybe cross multiply and put 4 over 1. Or, remember, we can just take the reciprocal of both sides. And if we take the reciprocal of the left, 1 over sine becomes sine. Then we need to do the reciprocal of the right side, and that turns into 1/4. Now we are able to solve this because we can just take the arcsine of both sides and arcsine of 1/4 will be our answer. And that is about 14.5 degrees. So down below then for secant, we know that secant is the same thing as 1 over cosine. Then we should do the reciprocal of both sides. So the left side is going to become cosine of y. And then the right side will become 1 over 2.0392. Remember, this is what I said in the last video. If you actually punch that into your calculator right away, I'm afraid that you will start rounding things that you shouldn't be, and it's going to be better if you just leave that as the exact value. And so that's what I'm doing here as well, so I know that my answer will be as accurate as possible. We don't want a bridge fail here. So then we are going to do the arc cosine, 1 divided by 2.0392. And that gives us that y was 60.63 degrees. So go ahead then, try to solve these on your own, pause the video. When you are done, then I will come back and I will show you how to solve them. Okay, now that you have done these, all of these we need to turn into their reciprocals first. So the first one, part A, secant, we know is going to be 1 over cosine, so I'm going to skip that step, and I'm just going to go straight into cosine of w equals, and that's going to be 1 over 5.4230. W is going to be equal to the arc cosine of that. Then when we type that into the calculator, we are going to get 79.37 degrees. Okay, for letter B, cosecant is the same thing as 1 over sine, so we're going to get sine of W is equal to 1 over 1.9340. Then we're going to take the arcsine of both sides. And then finally put it into the calculator. And that ends up being 31.14 degrees. And then finally letter C, so cotangent, is going to become tangent of W, and then the right side becomes 1 over 4.0921. Then we will do the arctangent of both sides, put that in the calculator, and there's your answer. So W in this case will be 13.73 degrees. Finally, we are going to be getting into, oh, sorry about that. I did not mean to switch there. Finally, what we're going to be getting into then is solving for the missing triangles. Finding the missing angles in these triangles. So, find to the nearest degree the measure of angle P in the diagram below. Well, what we need to do, if we're supposed to be finding angle P, we should put in theta right there. And now that we know which angle we were supposed to find, we should start labeling the sides of our triangle. 10 will be the hypotenuse. Across from theta is our opposite, and then the base here is the adjacent. We are not going to use the adjacent to solve this because there is nothing there, so we are going to use opposite and hypotenuse. And then from SOHCAHTOA, opposite and hypotenuse tells us that sine is what we will use. Now that we have that, we can go ahead and set up our equation. We have sine of theta equals, since it's opposite over hypotenuse, it'll be 4 over 10. And now this question just turns into like what we were doing on the previous slides. We just need to do the arcsine of both sides. And what we get when we do the arcsine of 4/10 is 23.58 degrees. And it said that we're supposed to write it as the nearest degree, so we'll round that to 24 degrees. Okay, so similar thing here. I want you then to find angle M. So pause the video, solve it, and then you can start it up again, and I will show you how to solve this. All right, so we have angle M that we're trying to find, so I will put theta there. Across from theta is the opposite side. Across from the right angle is the hypotenuse. The adjacent is between theta and the right angle. I can see that we will not use the hypotenuse in this question. So since we are left with O and A from SOHCAHTOA, that means that we are going to use tangent of theta. And O over A means that we're going to get 20 over 18. Now we are going to do the arctangent of both sides. And arctangent of 20 divided by 18 is 48.01 degrees. Now, I've chosen to include this one as well because I thought it was going to be a little bit confusing, and I decided that it would be good for me just to show you how to solve this. It says you're supposed to find the measures of the acute angles, and the side lengths are 5, 12, and 13. Now, we could just choose either angle E or angle C to solve. And I think, you know what, I'm just going to go with C first. So then we have to label our sides. There's the opposite, here's the adjacent, here's the hypotenuse. And let's go ahead and find measure of angle C. So I can honestly choose whatever I want. There's all three sides given. So I'm just thinking I want to do sine. So I'm just going to say sine of C is equal to 12 over 13 because we need opposite over hypotenuse. So then C will be equal to the arcsine of that, and then putting that into the calculator, we get 67.38 degrees. So that takes care of one of the angles. Now, let's say we don't want to subtract from 180 degrees. I know we could definitely do 180 minus 90 minus 67.38, and that's going to be equal to the measure of angle E. I know we can definitely do that. But let's say that instead of that, we want to use trigonometry in order to find angle E as well. We have a problem though. Our theta is currently at angle C, which means then that we have to go back to our triangle and we're going to have to relabel it. So I'm going to erase everything because now theta is going to be there. So our opposite side is now going to switch to be 5, our adjacent side is going to be 12, and then the hypotenuse is going to be 13. And now we can solve for angle E. So let's just say we want to do cosine this time because I want to use 12 over 13 again. So now we will get cosine of E equals 12 over 13 because SOHCAHTOA is adjacent over hypotenuse. E equals arccosine of that fraction. And then the measure of angle E will be 22.62 degrees. And then if we wanted to check, so our three angles are 90, 67.38, and then 22.62. And I can tell that those are going to be 180 degrees. So that is everything. The assignment is again going to be a worksheet. Go to Schoology and I will let you know what I expect you to do and which questions you can skip. Thank you for listening, everybody. Have a good day.